26. Assuming that no equilibria other than dissolution are involved, calculate the concentrations of the ions in a saturated solution of each of the following, and then see Appendix J for solubility products. So we need to find the concentrations of the ions in Ag2CrO4, and I went to Appendix J and I got the solubility product. That's the KSP value, and that's 9.0 times 10 to the negative 12. With every KSP comes a balanced equation. So we just have to write down the dissolution or dissolving this solid into its ions. So we have Ag2CrO4, that's a solid, and this will come to equilibrium between its two ions. Keep in mind that chromate is a polyatomic, so the split would be between the silver and the chromate. So I have Ag and then CrO4. Now, what are the charges in the upper right-hand corner between the Ag and the CrO4? You can always use your subscripts, right? There were 2 silvers, and remember, the 4 is part of the polyatomic. So you secretly had 1 chromate. So this 2 crisscrosses up, telling me that the chromate was a -2 charge, and this 1 crisscrosses up, telling me that the silver, the Ag, was a +1. So I have Ag +1 and the chromate -2. Now we just have to balance. There was 2 silvers, so I do have to put a 2 in front of here, but 1 chromate, 1 chromate. So we're good to go with that. So let's just pull this in a little bit. Okie dokie. And now let's just make our KSP equation, right? So KSP is just equal to the products because no solids allowed. So KSP would equal the concentration of Ag plus times the concentration of CrO4 minus, or 2 minus, and you just have to raise them both to their coefficients. So since there was a 2 in front of the silver, I have to raise the silver to the second power. And there was no number in front of the chromate, so that's a 1. You could raise this to the first, but that's the same as just leaving it. The KSP is the 9.0 times 10 to the negative 12. But the thing is that I don't know the concentration of Ag plus or CrO4 2 minus. But they did tell us that we had a saturated solution, which means that there's no common ions that are being added. So we could just use our variables here. So if we want to label what this is as a variable, I'm just going to label it as x. But it just has to go with the coefficient. So this would be 2x. You're just using your ratios to get your variables. And then since this one, the chromate is only 1, this would be 1x, but that's the same as just an x value. Okay. And these are now your values that go into your KSP equation. So the Ag is going to be 2x, and the chromate is going to be x. So let's go for it. 9.0 times 10 to the negative 12th equals, we have 2x, and that's squared, times x. 2x squared is the same thing as 2x times 2x. So you just multiply the numbers together. 2 times 2 is 4. And you pick up 2 x values, x and x, that's x squared. So I can just get rid of that. So this would be now 4x squared. I'm picking up another x value. So now I have a total of 3. So this would be 9.0 times 10 to the negative 12th equals 4x cubed. And now we're just solving for x. So divide on both sides by 4. And now I'm just going to move this over to the side a little bit just so that I can keep working. So we have actually, no, not x equals yet. Christina, what are you doing? So let's see. 9 times 10 to the negative 12th divided by 4 is 2.25 times 10 to the negative 12th. and that equals x cubed. Now you could do the cube root, or what I like to do is I just like to raise this to the inverse of the 3. This is 3 over 1, so if I raise it to the 1/3, that's essentially the cube root, this will cancel. But whatever I do on one side, I just have to do to the other. Okay. And now I will have x equals whatever it is. Let's see. We'll say 1.3. 1.3 times 10 to the -4th, and that's molarity. But now we're not done yet because they wanted the concentration of the ions. We have to go back to see what the x value was. Ag plus was 2x, and CrO4, 2 minus, was just an x. So if that's the case, if this was the x value, that's the chromate ion concentration, 1.3 times 10 to the -4th molarity. But then for the silver, you have to plug in the 1.3 times 10 to the -4th times that by 2. So this would essentially be 2.6 times 10 to the -4th molarity. And now we are done. And there is only 2 ions, so that's the end for this one. Okay. So, what'd you guys think? Stay tuned because I think there's a couple more letters in number 26, so hang tight if you guys are on the playlist, which I highly recommend you are. We'll be doing that in a few seconds. In the meantime, if you wouldn't mind pressing the subscribe button, thank you so much for that. And I will see you in a little bit. Okay, bye-bye.